So this is a short lightning talk about something that we call a lightweight fork. And so this is an idea we're poking at and poking around a little bit without sort of firm and concrete plans at this point. And so one question we've been asking ourselves is, what if we could fork a repo with sub-second latency and no storage overhead, right? If that was there from a tech side, from a product side, what would you do with it? And so scenarios that came to our mind were you could have a personal scratch space, very easily test something out that doesn't need to actually be out there in the public. You could do stuff like pull requests, right? Pull requests are all based on forks. You develop them in your own repo, and at some point you're comfortable, and so you request that they are merged back in the upstream repository. Or you could have a full-fledged editor and just use the repo as sort of backing file storage, right? We have change edits. You could already do that with change edits, but there you would kind of pollute the upstream repo with your sort of work in progress stuff. And so maybe that is something where you could store your edits. Or it could be an escape hatch for ever-growing repos. So one of the sort of scaling concerns we definitely have in Gerrit is that all of the pending state is stored in the repo, right? So all the patch sets, everything is stored in the repo. The evolution of patch sets, as well as changes that you have abandoned, that they remain in, and so on. So that could be sort of another idea. And so the other day I was Googling around a little bit, searching the internet, what is there in GitLab that I might not have seen. And so there's this nice Stack Overflow where someone asks, hey, what is an alternate object database? And the person explains, oh yeah, an alternate object database, it works like this and that, right? And so this is what it does. And then the person's like, oh, but what's tougher to describe is why would you use that, right? And I was like, hey, that's pretty cool. Maybe we could use that to do a lightweight fork. And so the sort of technical idea behind is you have a very large upstream repository, like Chromium source. It's a couple of tens of gigabytes in size. And then you actually want to fork that. And so you want to fork that in seconds. And so you can't copy the data in that time. And also it wouldn't make a lot of sense. And so what you do is you create this fork and you just tell Git that there is an alternate object database, which is the upstream one. And then the mechanism works as such that you actually have your own local object database that is read-write, and that's always the primary one you're interfacing with. And if an object is not found, then it sort of fails over naturally to the lightweight fork or to the alternate database, and then it just checks for the object in upstream. And so you would basically start with an exact copy of Chromium source in this case, as far as the objects go, and you start with your own local ref database. And so the local ref database is maybe only containing like one ref or so, maybe main or something. And you could sort of sync in the refs and you would really copy them over one by one because it's like a selective action. And yeah, that's pretty much it. And so the interesting thing here is that so JGit and CGit both already have this alternate mechanism. So JGit has this implemented also for file-backed repositories. And I think it's almost not used. At least I have not heard of any usages. So it's a little bit of a jewel hidden in the dark that really wants to see the light of the day, maybe. So there's a bunch of technical considerations here as well. So why did we call this idea like a lightweight fork? Well, the fork's own object database should be very small in comparison to the upstream database. And that is rooted in a bunch of sort of technical reasons that Git has. So if you think about garbage collection, for example, garbage collection produces bitmaps, and those are needed to actually serve the repo efficiently and serve it fast. But the bitmaps are only contained so they are sort of inside a PEG file and cannot reach over other PEG files. And so if in the first version of this, for example, you would have the bitmaps only in the upstream repo, but not in the fork. And that would mean there is sort of a scaling boundary in that fork, just because you don't generate these bitmaps. And there's a bunch of other sort of implications with GC that all don't play a role so long as the forks database is small in comparison to the upstream object database. And visibility and permissions, right? So Gerrit is known for its quite rich permission model. And so that doesn't really play well with this idea, because we already have a lot of problems enforcing these permissions in like standard normal repositories, right? Filtering the refs by visibility is tricky, and then following through and giving the user only the objects that they actually have access to based on the refs is already kind of complicated. And so I wouldn't want to imagine how you have that and then also have forks of this that have sort of partial visibility. So just from sort of product standpoint, it seems there would have to be a simpler model. Probably just you can read the entire repo or you cannot. And then when you can read the upstream repo, you can fork it, and then you can see everything in your fork. The infra is kind of moving a little bit in this area. So multi-pack index is something that the CGIT project has recently developed, recently meaning the last couple of years. So you can actually have an index file or multiple layers of index files that span several pack files. And this seems like it would come in handy here. So you have this large upstream pack, you have a pack of your own, and you actually have an index structure that sort of spans across everything. Generally, like if you look at other products, forks are really kind of an established concept product-wise. So it doesn't seem very risky from a product perspective to do something in this area. It seems like this is like a universally accepted concept at this point. Yeah, this was actually it already. So this is a lightning talk. So I was only planning to talk for 5 minutes and hoping for some discussion with all of you. I think that would work, right? So the way I would imagine this lightweight fork is sort of everything that happens in the fork is private to you or to whatever audience you share, and you would create a pull request or a change by sort of upstreaming that change by basically like making a copy of the change when you're ready and like upstreaming it into the repository. And then at that point, I think it can actually get like a number that is unique only in this repo. That is possible today, so that's the way it's implemented. You can have more than one alternate, though we were a little bit skeptical of how do you make it so that you don't allow infinite chains or chains of sizes that would like cause trouble downstream. So the first shot that sort of we had in this idea was maybe to just restrict it to sort of one depth of one. So you can fork a public repo, but nobody can fork your fork. But this is something I think that you can iterate on over the course of the feature.
Exactly. I believe the question was, do you foresee the ability to fork a fork, basically?
Yeah, that's something that I think you can sort of iterate on. So we thought that, at some point, maybe pull requests are interesting, maybe not. It's always like there are these topics in Gerrit where for years we've been going, maybe not, right? And so this could be one sort of piece of supporting infrastructure, but also just the personal scratch space, right? The implementation for all of this is like very small, I think, especially, let's say you don't do pull request, you just want a personal scratch space, right? Then the implementation for this is super, super small. Like if the support in JGit is there, then you offer an API to create a fork, and like then it behaves like a normal repo, minus the fact that you can't create changes. Correct. That's the vision. Yeah.
Thank you very much, Patrick, for joining.
Thank you
remotely.